The next lesson we're going to look at is how we can take 2-butene, either cis-2-butene or trans-2-butene, and change it into butane. Okay, the reaction that we're going to look at now takes 1-butene and changes it into butane. How does it do that? We take H2, which is a gas, and we bubble it in a solution with a metal catalyst, either platinum, palladium, or nickel. Now, the interesting thing about this reaction is not what it does, is the epiphany that happens when you hear some of the phrases that we're going to talk about. So this structure that has a double bond is called unsaturated. In this structure that doesn't have a double bond, it's called saturated. We've heard these phrases when we've talked about fats, and that's where the fun part is. But let's go on and let's look at what happens when you take the same reaction and treat propyne with it. Well, you treat propyne, H2, let's choose one of these 3 metal catalysts. Let's do platinum. Remember, if it's above the arrow, it's usually in excess. So if we have excess H2, what we'll end up with is propane. So how does this work? Well, here is the surface of the metal. I'm going to draw the metal underneath. So here's our metal. And we bubble in a gas, hydrogen, and it attaches to the orbitals or empty orbitals on the metal. And the bonds weaken. So we end up sort of charging the metal with a surface of hydrogen atoms. Now, here is our double bond. Actually, let's take cis-2-butene because it's easy to draw. And it floats down toward the surface of the metal. Then, if you remember, I'm going to draw it like pi bond. So here are our 2 p orbitals overlapping. They're going to pick up the H's. So when we're done, we'll end up with H's and no pi bond. And remember, there were already H's here in the first place. So we end up with a saturated hydrocarbon. Now, since the H's were added on the same side, this is called a syn addition. That's not really important when we're making something like this, which has all sigma bonds, because there's no such thing as stereoisomers. The interesting thing is when you take a compound such as 1,2-dimethyl cyclohexene and treat it with H2, and let's use palladium this time, what's going to happen is the H's add to the same side. The double bond disappears, and you end up with cis 1,2-dimethyl. Let's put the CH3s to make sure you know what they are. Cis 1,2-dimethyl cyclohexane. Something similar happens when you reduce internal alkynes. So if I reduce with what's called Lindlar's catalyst, which is a form of a palladium catalyst that stops at the double bond. If I take 2-butene and treat it with H2 and Lindlar's catalyst, what happens is the H's add to the same side, and you end up with cis-2-butene. There's a complementary reaction, which we're not going to do in this class, but when you take sodium metal and NH3, you end up with trans-2-butene. I also want to reiterate that the things above the arrow are usually in excess. So if I have a compound like this, say with multiple double bonds, and I treat it with H2 and nickel, we're going to think this is in excess, and you end up with no double bonds left. So why do I think this is really cool? Well, when you take vegetable oil, like corn oil or canola oil, vegetable oil is liquid. And it's liquid because it has lots of cis double bonds. They don't stack together very well. And so they end up being liquid. You treat it with H2 and say PT. You end up with hydrogenated vegetable oil. Now, the other name for hydrogenated vegetable oil is shortening or margarine. This is unsaturated fat. This is a saturated fat. Oh my goodness, these are words you've seen before. Now, the other cool thing is, say you don't completely hydrogenate it. Say you partially hydrogenate it. And what you get is, instead of all these cis double bonds, they flip on the surface of the metal. And instead of completely being hydrogenated, they end up being trans double bonds, which is where the word of trans fats comes around. And I'm not exactly sure why, but trans fats have a different mouthfeel than the normal cis fats. And they have used trans fats to make food more appealing. But because trans fats are unnatural, your body has not as many mechanisms to break them down as cis fats. And so that's why trans fats have a bad name. And that's the fun part of this little lesson.